Okay, this is going to be the Algebra 2 Chapter 3 sample test. This is new for 2014, so make sure you use your sample test and follow along with your calculator. Okay, first problem here is g plus f of 3a. So what I'm going to do is I'm going to do x, basically I'm going to do x squared minus x plus, all right, f, which is 4x, okay, all right. Now, what you can do, a number of different things. What I would do here is I would combine my like terms, so I'd have x squared plus 4x. Now, since it says 3a, what we want to do is we want to put 3a in every spot where we see x, okay? So the idea there is 3a squared would be 9a squared plus 12a, okay? For convenience sake, I'm going to go ahead and do this side of the board as well. G of f of x. So that means I'm going to start with that function. This is a composition. So I'm going to start with that function, and I am going to put a parentheses every spot where I see x. The thing I'm going to fill in is this next function. So I'm going to fill in f, which is 4x. Now, since it says 2, what I'm going to do is I'm going to go into my calculator. All right, I'm going to go to run. And since they want me to find a value, I'm going to put 2 in, 2, and then this arrow right there, 4x. Okay, and then I'm just going to type it in exactly like I see it. All right, so I would use this this tool. That way you don't make any mistakes in the calculation. So that's 56. Okay, moving right along. Okay, I believe this is supposed to be multiplication. All right, that's supposed to be multiplication. That's not a composition, so it's a little different. So multiplication, I'm going to do x squared minus x. All right, times f, which is 4x, okay? So this is a distributing problem, so that's going to be 4x cubed minus 4x squared, and I'm done for right there. All right, this is g of, now this is a composition, so I'm going to start with g, okay, let's figure out what the g function, x squared minus x, okay, so I'm going to do x squared minus x. What am I going to put inside of there? I'm putting in k. K is square root of x plus 3, square root of x plus 3, square root of x plus 3. Now, what happens here is this. The square gets rid of that square root, so I'm left with x plus 3 minus, and nothing's going to happen with this, it's going to be x plus 3. Nothing combines here, so this is going to be my final answer, okay? Moving on to these next two. F minus, okay? All right, now this is subtraction, so what's my f function? 4x, okay, so I'm going to do 4x minus, okay? 4x minus, h. H is 2x minus 1, okay? Now, there's two rules of thumb you can think about this. If it's subtraction, what subtraction does is it turns around all of those signs. So that's a fast way to do it, okay? So basically, if that's 2x, now it's negative, that's negative, now it's positive. If I combine my like terms, 4x minus 2x, the 1 stays there because it's not like, that's my answer there. Here's a composition. So let's start with h. H is going to be 2x minus 1. So 2x minus 1, I remove the x. I'm going to put the g function inside there. G function is x squared minus x. So I'm going to distribute. That's 2x squared minus 2x minus 1. Okay? And that's going to be my answer there. All right? All right. 4. K of g of 1/2. All right? K is square root of x plus 3. All right? Square root of x plus 3. Now instead of x, I'm going to put that plus 3 right there, okay? All right, and then I'm filling in, what function am I filling in? G. Sorry for all the flipping back and forth. X squared minus x. All right, x squared minus x, okay? Now, here's a good rule of thumb that I would use. I would go ahead and figure out just this inside part first, all right? So what I would do there with that is I would do, I'm going to put in 1/2, 1 divided by 2, in for x. And I'm going to go ahead and type this in. I'm typing in parentheses x squared minus x, all right, plus 3. All right, I'm getting that amount. And now I should be able to take the square root of 2.75. All right, that probably makes things easier, 1.65, okay? I think that makes it 1.65, all right? Decimals right there. All right, g of x, okay? So the g function here is x squared minus x. Okay, so x squared minus x. All right, and x squared minus x is what I'm filling in here. All Okay? Now with this, what I would do is that's going to be the boxes. So x squared and negative x squared and negative x. So I got x to the fourth, negative x cubed. This times this would be negative x cubed. This times this would be positive x squared. Okay? All right. Basically, that's going to be x to the fourth. These are now all going to turn around signs, so that's going to be negative x plus x. So I got x to the fourth. All right, two of those would be negative 2x cubed. X squared and x squared would cancel out. Plus x would be my remaining. Okay, I think that's it for that page. Okay, this is a continuation of the Algebra 2 Chapter 3 sample test from 2014. We're now going to move on to the inverse portion. Okay, basically what you're going to do with inverse is the first thing you're going to do is going to switch x and y. All right, then you're going to solve for y. Now, if anything's attached to y, we leave that for last. Okay, so that's going to be last. So what we're going to do is 5 is going to move over here, and you're going to do it the opposite. So that's going to be x minus 5. Those do not combine. I'm going to divide everything by 4. So my inverse is x minus 5 all divided by 4. Okay, that's the symbol for inverse. For log, all right, what you want to do is switch x and y first. Okay, now log is going to be a little bit different because what you're going to want to do is you're going to get the log piece by itself. So this 3 is going to have to move over to here. So that's going to become x minus 3 equals the log of 7y. Now, with log, you've got to create that into an exponential. So the base is going to be the same, okay? All right, and basically, it's no longer going to equal x minus 3. It's going to equal y. The x minus 3 is going to go up here. So my inverse is 7 to the x minus 3, okay? All right. So basically, the log conversion. If you want like just a generic example, let's say you have this. Okay. Basically, the base, whatever the base is still going to be the base. If you want to put it right here, that's fine. It's going to be the base of the exponential. Now, this is no longer going to equal a. So there's basically 3 parts. Here's a part. Here's a part. Here's a part. All right, so here's this part. Now, we've used this already. It's these two, A and C. It's not going to equal the same thing, so this has got to be C, and this has got to be A. All right, and then you can manipulate it from there, okay? Just moving down, let's stay with the log one real quick. So if what this is here, this is log base 10 if you don't see it. Okay, so what you have here is you have x equals, all right, log base 10, 2x minus 5, okay? Now, what's going to happen is the base of the exponential is going to be 10. All right. I'm sorry, this should be 2y. All right. This is no longer going to equal x. It's going to equal 2y minus 5. This whole part's going to come over. X is going to become the exponential of that. Now I want to solve for y. So 5 is going to move over here and now become positive. And I'm going to divide everything by 2. Okay. So my inverse here for this is going to be 10 to the x plus 5 all divided by 2. Okay, staying with that exponential since we're working with that. All right, I can't move any of that yet, so what I'm going to do, all right, I'm going to switch x and y. All right, so now I got to convert it to a log. So now it's going to be log base of 6. That base is still going to stay the same. All right, it's no longer going to equal x. It's going to equal y plus 1. The x is going right here. I got to get y by itself, so the 1's going to go over here as minus. Okay, so I got inverse log 6 with the x minus 1. Okay, staying with the exponential. Okay, I'll come back to these other ones in a second. X equals 3, y minus 2 plus 7. Okay, we got to isolate the exponential, so that's going to be x minus 7 equals 3y minus 2. Okay, now it's time to create into a log. So the log base of 3 is going to be the same. It's no longer going to equal that. That's going to go right over here. Okay, y minus 2 is going to go right there. So the negative 2 will come over as plus. Okay, so I got inverse is going to be log base 3 x minus 7 plus 2. Okay, and there's my answer. All right, I think that's all those. So let me go back to these inverse ones up here. Okay, so basically, just to summarize the log stuff, understand, let me make that a little cleaner so you can see. Understand that basically, whatever is the base here will be the base of the exponential. whatever it equaled to before, it can't equal again. So there's only 3 parts, 1, 2, and 3. So it's got to be the C right there, okay? Now for this one, where f of x is here, that's a fancy symbol for y. Switch x and y, okay? Now I got to get y by itself, so the 1's going to come over as -1. And to get rid of that, I'm going to square root plus and minus both sides. So I got plus and minus square root of x minus 1, okay? All right, so square root in that, all right? That's going to be y. X minus 3 plus 4. I'm switching x and y. Okay? 4 comes over, so it's minus 4. Alright? To get rid of the squared part, I'm going to square that, square that. So what I have is x minus 4 squared, alright, equals y minus 3. The -3 is going to come over as plus. So what I'm going to have here is f inverse of x equals x minus 4 squared, okay, plus 3. Okay, and that answers for this problem here. All right, this one, x equals 2 square root of y plus 5. Okay, the x is going to come over. All right, and I got 2 square root of y. Okay, all right, you can do a couple different things here. What I would do is get these are attached by multiplication, so this is going to end up being x minus 5 over 2 equals square root of y. Once again, I'm going to square the whole thing, so I got to square the whole thing here. So what my inverse would be, okay, is x minus 5 over 2 squared, okay? Use composition to determine if they're inverses, okay? So what you have to do is you have to use on your own, you have to use the concept of f of g of x, okay? So what I'm going to start with is I'm going to start with f, which is this. Okay. Now, what's going to go inside there for me? Okay, I need probably need a little bit more space. Okay, what's going to go inside there for me is the square root of x plus 2 minus 3. Okay. Now, if you square that, that's going to basically be square root of x plus 2 minus 2. All right, plus 3. And the goal is this should equal x. Okay. And the fact of the matter is, it does not, okay? It does not equal x, so that one's going to be no, okay? That's going to be no. All right, this one, let me see what that is real quick. Sort of hard to see on that screen. All right, let's move that right there. All right, this, I would start with f of g of x. Okay, all right, f of g of x. So I'm going to start with 3 plus 4. I'm putting 1/3 x minus 4/3 in there. Okay, when I multiply that, that's going to be 1x minus 4 plus 4. So I got 1x. Okay, that's good. Now I just got to do the other thing for the other side. G of f of x. Okay, so I'm going to start with g, which is 1/3 space minus 4/3. Okay, I'm going to put now 3x plus 4 in there. Okay, so if I distribute that, that's 1x plus 4/3 minus 4/3, so that's 1x. That's also good, so that answer is yes. This answer was no because nothing canceled out there. Okay? Let's go to the next page. All right. All right, which ones are true and false? Okay, all right, when you go from one to the other, inverse is basically you're switching x and y. Okay, so that happens, that's true, okay? All right, it's a reflection, yes, that's true, okay? Inverse is always a function, that's going to be false. Okay, this is false. This should equal positive x, okay? All right, if the domain is this, then the range is this. No, the range would be, okay, if that is that, all right, the only thing that tells you, the domain of this would be, you'd have to have a y. So the range, if this was the first one, the range would be y is greater than or equal to 3. So that's also false. All right. All right, let's move to this one. Okay. All right, given that, label f of x and that on the same line. Now what I would do is let's go ahead and make a table All right, so x and 2x plus 4. I'm just going to use some simple values. Let's say 0 and 1. All right, if I put 0 in there, that would end up giving me 4. If I put 1 in there, that would give me 6. So 0 over 1, 2, 3, 4. 1 over 6 up. So here's what I got. Okay, so this is f of x. Okay, now to get the inverse, all right, all you have to do is switch around your x and y values. Okay, so 4, 0, 1, 2, 3, 1, 2, 3, 4, and 6 over 1 up. All right, here's what I got for that. So here's my inverse, okay? So to get the inverse from one to the other, all you're doing is switching x and y. Okay? All right? Determine if these are inverses. Now, here's how I would do this. Look at this first one. This crosses at 0, -2. Well, for the other one to be an inverse, it would have to cross at -2, 0. And that does not happen, so that answer is no. Okay? All right? So you got to look at the points. So they got to be able to flip. All right? Graph below, graph it on the same axis. Okay? Once again, here's how I would do that. 3, 0. Okay? 0, 1. So when I make the next one, what I would do is graph 0, 3. 1, 2, 3. Okay, that's 0, 3. And, okay, 1, 0. And what that's going to do is go like this. Okay? All right, it's going to go like that. All right? I think. Okay, anchor, anchor. Actually, I'm sorry. That's not the way it's going to go. It's going to go this way. Okay? Sorry about that. Yeah, anchor points and anchor points are going to stay the same. All right? All right. Okay. Lewis has the following. Okay? Has the following work on his homework. F of -1 of 6 equals 10. Explain why he must be wrong, because it should equal the same thing. It should be 10. I think that's it for that page. Okay, so this is conversions. Once again, this is actually pretty easy. So if this is an exponential, I'm keeping the base there. Okay, like I said, there's the 3 parts. So it's no longer going to equal 2, it's going to equal 289. The 2 is going to go in the exponential part. Okay. This one, the base is going to be 5. It's no longer going to be -3. It's going to be 1 over 125. The -3 is going to go there. All right. To rewrite them in log form. Okay. All right. To rewrite them in log form. So basically, this log will have the same base of y. All right. It's no longer going to equal 144. It's going to equal x. Okay. Same thing here. This is going to be the log of 196. Okay. Not going to equal 1 over 14. It's going to be -1/2. The 1 over 14 goes right there. Okay. Graph the following transformations. Okay. All right. So for exponential, 0, 1. All right. And 2. Okay. Now your anchor point here, all right, is going to be 0, 0. Okay. So what that means is I'm going to have, since it's an exponential, I'm going to have a horizontal asymptote. So for exponentials, that's a horizontal asymptote through 0, 0. Okay? Now, when I substitute these values in, that's going to be 1, 3, and 9. So from 0 over, 1 up. Okay? 1 over, 1, 2, 3 up. 2 over, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? So what's it going to do is it's going to approach that one and go through that. Okay? All right? If you look at this one, all right, normally we're going to treat that at first. All right, first the anchor point is 0, 0. Since it's a log, I'm going to have a vertical asymptote. Okay? Now, since that base is 2, what I treat it as is 2 to the x. Okay? Hopefully you can see that. All right? So that I'm going to use 0, 1, and 2. All right? Maybe 3. All right? 2 to that would be 1, 2, 2 to the second will be 2, 2 to the third will be 8. Now, since it's a log, I'm going to use the inverse, okay? So the inverse, so that's going to be 1, 0, 2, 1, all right? I'm sorry, that shouldn't be 2, 2, that should be 2, 4. I made a mistake there. All right, 2 to the second is 4, 2 to the third is 8, okay? So that's going to be 4, 2, and 8, 3. So from this point, I'm going 1 right, 0, 2 right, 1, 4 right, 1, 2, 3, 4, 2, 8, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And what happens is it approaches the asymptote, goes through that. Okay? All right? Moving on to this one. Okay? Now, your anchor point for this one is going to be 1, 0. Okay? Because remember, we're opposite. So for the exponential, that's like the inside part. We're doing opposite there. So I'm 1 over 0. Since it's an exponential, I'm going to go this way. Okay? Once again, I'm using 0, 1, 2, and 3. All right, x, 2x. The reason why back here we don't use 3 is because 3 to the third would be 27. That's going to be way off. Okay? All right. So 2 to the 0, 1, 2, 4, and 8. So this is 0 over 1 up. Okay? 1 over 2 up. 2 over 1, 2, 1, 2, 3, 4 up. And 3 over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So basically, and that's going to pass through there. Basically, what you should do is your anchor point determines which one of where the asymptote. Exponential goes through this way, log goes through this way. Okay? All right. All right, so what we have on this one is we have 3 to the x. Okay? I'm going to skip that one for right now. Okay? All right. See your teacher for that one. All right. Okay. Graph by transformations. Okay. So what we're going to do is we're going to have to graph this. Okay? All right. And then what we're going to have to do is find these different results. Okay. So since this anchor is going to be 0, 9. Okay? It's going to be 0, 9. All right, so 0 over 1, 2, 3, 4, 5, 6, 7, 8, and 9. Be right here. Since it is a exponential, it's going to go through this. Okay? All right, 3 to the x, 0, 1, and 2. So that's going to be 1, 3, and 9. Now, since I have this negative in front, I'm going to multiply by -1, which is -1, -3, and -9. Okay? So 0 over, -1 down, 1 over 3 down, 1 over 1, 2, 3. Always go off of the anchor point. And 2 over 9 down. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Oops, that should. So. Good. Okay, so what this is going to do is going to approach this and go straight down. That's not a very good drawing. Okay, all right. So when I answer the questions here, the 0, we're going to say that's about x equals 2. It's pretty close, which makes that 2, 0. Okay, the y-intercept that crosses up at 8. Okay, so 0, 8. Okay, vertical asymptote. This is a horizontal, so I have none there for vertical. Okay, my horizontal asymptote is going through at 9, so that's going to be y equals 9. Okay, now this arrow is a left arrow, but it's going flat. So the y-coordinate, it's getting flat at 9, not at infinity. This is a right arrow, okay, and that is going down. Okay. To do increasing, decreasing, I still start left to right. So that's all decreasing. Okay? So that's -infinity to infinity. This is none. Okay? As x approaches infinity. Okay? As x approaches infinity, I have an answer of -infinity. As x approaches -infinity, I have an answer of 9, because that's where it's flattening out at. Okay? And I think that's it for that. Okay? The domain. Okay? Once again, the smallest x value is -infinity. The biggest x value is positive. Okay? So for domain, the smallest was negative. The biggest was positive. So that makes the domain all real numbers. Okay? Makes the domain all real numbers. Now, the range. All right? Now, you have to include your anchor point in this. So my smallest y value is 9. Okay? It's going to be 9. Now, I don't put a line underneath that because that passes through the asymptote. It's a dashed line. The biggest one I'm sorry, I did that wrong. Yeah, no, I'm sorry, the smallest one is going to be negative infinity. The biggest one is going to be 9, and I'm not having a line underneath that because that's an asymptote. So I got y such that y is less than 9, okay? All right, so that's that one. Let's go ahead and do this log problem. Okay, the anchor here is going to be -3, -2. Okay, all right, so 1, 2, 3, 1, 2. All right, it's going to have a vertical asymptote through it. Okay, all right, since it's, I'm going to use x and 3 to the x, so that's going to be 1, or 0, I'm sorry, 0, 1, 1 is 3, 2, and 9. Since it's the inverse, though, I'm flipping those around. Inverse, okay? So 1, 0 from this, okay? 3, 1, 1, 2, 3, up 1. 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, and 2, okay? And so this is going to do this number, okay? Now, as far as labeling the graph, this is a right arrow, positive, positive, okay? This left arrow, all right, now, it's going straight down, so the y-coordinate is actually negative infinity, but here's the deal, it's going to stop right there, so I'm going to actually have that as -3 there, all right? So now the zeros, that crosses at 1, 2, 3, 4, 5, 6, it crosses at 6, so that's going to be x equals 6, that's going to be 6, 0 for that intercept, that crosses at -1, so 0, -1. Vertical is at x equals 1, 2, and -3. We have none for this. Okay? This is increasing completely, but it's increasing from -3 to infinity. The reason why we don't go past 3 is the asymptote cuts us off there. It's not decreasing at all. Okay? The end behavior, as x approaches infinity, okay? As x approaches infinity, we have that as positive. As x approaches negative infinity, it's actually going to be still negative. As x approaches, ironically, -3, it's also going to be negative. All right? So that's that answer there. Okay? All right. All right, the domain. The smallest x value that I have here is -3. The biggest that I have is infinity. Now, once again, I don't have a line under that because, all right, it's an asymptote. The range, the smallest y value I have is negative infinity. The biggest one is positive. So that one's going to be all real numbers. Okay? All right? All right. Write an equation where the function would have a range of y is less than 2. All right, what that has to be is it's got to be an exponential. So it's probably got to have something where the anchor point is going to be at 2. So maybe something, let's not confuse you. Let's say it's something like this, okay? Because then the anchor would be at 0, 2, okay? All right, it would be at 0, 2. And then the thing would go underneath it, like this, okay? So there's an example of that. State the solutions and mark them on your graph. All right, this is just from last chapter, okay? So what I'm going to do is go into menu and graph, all right? What I'm going to graph first is going to be the right side, which is 1. Then I'm doing option num, ABS, x plus 4, all right, -2. I'm drawing, we fixed it, F3, F3, X and draw. G solve, intersect, so I got -7, 1, and -1, 1. Okay, so my answers are x equals -7, x equals -1. Okay, all right, so -7, 1, 2, 3, 4, 5, 6, and 7, up 1. -1, 1. The anchor here is going to be -4, -2. 1, 2, 3, 4, down 1, 2. So this is what it looks like. Goes through there, crosses like that. Okay? All right. On part B, okay? Part B, the grid is optional. You can just do the number line. Okay, so I'm going back into here. All right, I'm deleting everything I got. I graph the right side first, so I'm going to take that exact inequality, type F2. All right, option num. All right, x minus 6. Okay, and then I'm going to flip that around, type. All right, 3. All right, and I'm going to draw. All right, I'm going to zoom auto. All right, let's try zooming out. Now, what did I do here? Oh, forgot my ABS. There we go. All right, G-solve intersect. I got three. All right, so I got 3 on my number line with an open circle. Okay. If I hit the over button, I go to 9. Okay. So 9 is going to have an open circle, and as you can see, the shading is on the outside. So this is x is less than 3, x is greater than 9. Okay. And I think that is it. Okay, that's it for that review video. These will probably be combined as, hopefully I can combine them as 2 to get those first 1 through 8 questions. If not, they'll be 2 separate videos.